Hi everyone, this is Shannon Anatomy Physiology, discussion board 5, and I'm going to give you a quick review and comparison of the structural differences and functional differences of the vessels. And I'm not going to give you a piano lesson. Looks like. Okay, so let's start off. First off, so we've got a good example is the conducting artery, which is conducting artery is one of the aorta. So that actually is a good example to start with. The structural difference of a artery and a vein, to start with, very obvious, is the lumen. The lumen in the artery is a lot larger. And it's a lot larger because the artery is going to be getting a higher velocity of blood, which is going to have a higher blood pressure. So it's going to allow the blood to pump through the artery stronger. We have the tunica interna in the endothelium. It's the same thing, and actually the tunica interna is has a simple squamous epithelial tissue and a basement membrane. And then we have the tunica media right below that. And what that has is the smooth muscle, and the smooth muscle allows for the different changes in diameter and the change in size of the vessels. So when the blood's pumping through there possibly harder, it's going to be larger and it might constrict at other times. Then we're going to have the vasorum, which is a vessel. And so the arteries carry blood from the heart to the body. Functionally, that's a difference. And the veins carry blood from the rest of the body back to the heart. The arteries carry oxygenated blood, and almost all veins carry deoxygenated blood. An exception is the pulmonary veins, which carries oxygenated blood from the lungs to the heart. Arteries also have a thick elastic muscles, veins much thinner. Arteries have a much narrower lumen, which we just discussed. So let's go down to look at the vein. This is a medium. Excuse me, my voice. I'm getting over a bad cold. And so the lumen in the vein is a lot smaller. You're not going to have as high blood pressure going through the vein. One of the obvious differences structurally between the artery and the vein is the valve. The valve has to be in the vein to actually prevent backflow of blood. So because the blood pressure is a lot slower going through the vein, there may be the possibility of blood not rushing through in the correct direction, so there is a valve to prevent that. There is the tunica interna, which is similar as in the artery. We have the basement membrane, the tunica media, same as in the artery, and we have the tunica externa, same as in the artery. So the differences are very obvious with the valve, with the size of the lumen, and the diastolic pressure is the lowest pressure, and it's occurring during ventricular relaxation between heartbeats. The highest pressure in the arteries is when the ventricles are contracting, is known as systolic pressure. And then we're going to go down to the capillaries. They have the endothelium, which is it makes up most of the capillary, and then the basement membrane. There are no larger structures, no valves. The lumen's very, very small. Capillaries are the smallest vessels. They're found at sites of exchange between blood and surrounding tissues. Capillaries exchange gases, nutrients, waste, and products. Capillaries only consist of endothelium and thin basement membrane. They lack a tunic and an externa and a tunica media. They allow they're highly permeable, so they allow for the exchange of substances and for the surrounding tissues. They're very permeable, which is very important, so that blood can circulate and get to tissues that not necessarily the arteries can get to in the veins. So these are the structural differences, very obvious if you look at them from my drawing. And then the functional differences is that the arteries are going to carry blood from the heart to the body. The veins carry blood from the rest of the body back to the heart. And also very obvious, this is a good, interesting little fact I like, is that, you know, when you have red blood vessels, that means it's oxygenated blood within the vessels when they're red, and when they're blue, it means they're deoxygenated blood. So that's another very obvious structural difference when you look at them. Thank you very much for our quick little video. It's a little close. Thank you very much. Have a great day.